Hey, in this video we're going to actually practice graphing the proportional lines that we started exploring a little bit in our last video. And friendly reminder that in these proportional relationships, our equations are always y equals mx, where m is the coefficient and now called the slope, and x is an input with y as an output. Let's just kind of dive on in here. All right, so using some proportional relationships from the page where you had to decide if they were proportional or not proportional, I just pulled a few of the tables of values, and we're going to explore the equations and how they relate to the table. We're going to graph a line over here on the coordinate plane, and we're going to explore a few key features that these things might have in common. We're also going to talk about something today called a staircase, and I will point that out once we have a graph. Okay? All right, so first thing we're going to look at here is a reminder of the equation y equals 3x. And the reason we have this equation here is because each input, you multiply it by 3 to get the output. So 2 times 3, 1 times 3, 0 times 3, and negative 1 times 3 is negative 3. We talked in the last video about how all these proportional graphs will go through the origin, and that's because 3 times 0, the answer is 0. So inputting a 0 will always give you an output of 0 as long as you're using multiplication. So I'm actually going to start there. I'm going to plot that very first point, the origin. Go ahead on your coordinate plane over here. Let's plot the origin. We know that this graph is going to go through that point. On yours, I want you to also plot this point, negative 1, negative 3. So from the origin, remember we go back 1 and then down 3. You can plot a point at 1, 3. So let's go from the origin over 1 up 3 and plot your point. And then from the origin, if we went over 2 up 6. So this is the line for y equals 3x. Now the purpose of this video today is to actually explore the staircase in the line. And when I say staircase, I'm actually talking about the slope. Now the staircase from point to point, let's talk about the staircase, okay? If I'm trying to go from this red point to this blue point, I'm going to go, here's my little staircase. See how I built a little staircase? I'm just going to kind of draw one in here. Don't make it look like a flight of steps. And that one was a little crooked. Sorry. There we go. So the staircase, let's talk about the staircase, okay? I'm going up 3 and then over 1. I go up 3 and then over 1. I go up 3 over 1. So I just said that I was going up 3 over 1 every time. Now that rate of change, that is the 3 that we see right here. Okay? So the staircase from point to point in this example, we went up 3 over 1, up 3 over 1. So my staircase is up 3 over 1. Okay? Now, this is a brief little tidbit that I want to point out. If, for whatever reason, let's just pretend in the unit you somehow end up going backwards. Let's say you look at it like this. Boop, 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 boop. I don't expect anybody will, but this one is going down 3 and then back 1. And since a negative divided by a negative is also a positive number, that's still the positive 3 that happens right there. But I'm going to undo that just because I don't want anybody to get confused, but I'm just trying to point out that even if you did it that way, it would still work, okay? So my staircase here again, I went up 3 and then over 1, up 3 over 1, up 3 over 1, okay? All right, now let's look at the next proportional example. Now this one was just a whole number, but the staircase is still up 3 over 1. And I want to point out that 3 divided by 1 is just a 3, so it's okay that I write a 3 right here. All right, now for the next one. This equation was 1/2 x because if we take a half of each of these, we get these. So half of 2 is 1, half of 0 is 0, and again, it's going to go through the origin. If I did a half of negative 2, I get negative 1, and half of this, I get this. So let's just go ahead and plot these points in our table of values. The origin, I'm just going to go ahead and plot the origin because they always have the origin. Now let's look at this first green point here. We've got negative 4, negative 2. So from the origin, we're going to go back 4, down 2, plot your point on your notes. We've got negative 2, negative 1, plot your point. We already took care of the origin, and then the next one was over 2, up 1. So we've plotted our points, and here is our line. Cool. So we know that the key features of the graph, the line here is going to go through 0, 0. Got it. And now let's talk about the staircase from point to point. Okay? If I'm going to build my staircase, take a look at my little staircase here. See how this time for the staircase, I'm going up 1, and then I go over 2. I go up 1, and then over 2, and then up 1, over 2. So my staircase here is going up 1, and then over 2. I went up 1, over 2. First, up here, remember I went up 3 over 1. There's up 3 over 1, up 3 over 1. This one is up 1 over 2, up 1 over 2, up 1 over 2. So the staircase that's in the background, you might notice that the little staircase is my slope, okay? So our proportional graphs down here, proportional graphs will always pass through the origin, we know that, because anytime we multiply a number by 0, the answer is always 0. If you're going to plug in a 0, your answer will always be a 0. So proportional graphs, y'all, always go through the origin. I can't say this enough. If I were to come up here and graph this line and ask you if it's proportional, you would say no, because it doesn't go through the origin. If I were to give you this line and ask if it's proportional, you would say, yeah, it goes right through the origin. If I gave you this line, yes, proportional, because it goes through the origin, but this one, not proportional, because it doesn't go through the origin, okay? All right, so let's just kind of practice again, proportional table of values. So if our equation is 3x, 2 times 3, my output would be a 6. If I had a proportional table and the equation was 3, I would do 3 times 1 and get a 3. I would do 3 times 0 and get a 0. And I would do 3 times -1 and get a -3. Okay? So once again, here is the origin, 0, 0. It's right there. All right, now let's do the next proportional graph. If we were to have a 1/2 x and we wanted to fill out the table of values, we would do a half of -6 and get a -3. I can do a half of -4 and get a -2. I can do a half of 0 and get 0, and a half of 4 and get 2. So again, I'm dividing every time in this table, but we're using a fraction to show take a half of it. And once again, I can see the proportional 0, 0 right there. This looks like a typo on mine. This is a 3. Let's make this a 4. My bad. Let's just make that a 4. So -1 times 4 is -4. 0 times 4 is 0. Again, anytime you input a 0, the answer is always 0. And that's just what I'm trying to prove for proportional graphs. You're always going to have, I can highlight it here, you will always have the origin in the table of values. Okay? All right, 1 times 4 is 4, and then 2 times 4 is 8. There we go. And now let's do divide by 5 or take a fifth. Okay? If you do this divided by 5, you get a -2. Divided by 5, because again, taking a fifth is the same as divide by 5, this is a -1. 0 divided by 5 is 0, and 5 divided by 5 is 1. So we've taken a fifth of each of our x's, and we can see again, there is the 0, 0. So our proportional graphs will always pass through the origin. All right, and again, the other part of this video was to start to talk about the staircase. I'm reiterating that they both go through the origin, and my little staircase is actually the coefficient. My little staircase is actually the coefficient. So let's actually practice how to graph the line using just this coefficient, aka the staircase. All right, now in this one, we see that the coefficient is a 3. Okay? Now, to make it a staircase, I need to make it a fraction. I'm going to put over 1. We already said that we know because it's multiplication that the proportional should pass through the origin. So without looking at any points or plotting any points using just my staircase from the origin, I'm now going to go up 3 over 1, up 3 over 1. Now, I'm not really drawing in the staircase. You see how I'm not actually drawing it in when I was plotting the points? There, I just drew it in now. But let me undo that. I don't want to actually have to draw the staircase. I just want to use the staircase to plot the points. Now, again, because I've started to go this way by going up and over, and I'm running out of room, I could go down 3 and back 1, and down 3 and back 1. And again, technically a negative divided by a negative is a positive, so that all still works out. And I'm going to connect here. You should have rulers for these today, so make sure you've got your rulers to connect your lines just so they look good. And what we did, y'all, was we just graphed y equals 3x without even needing to look at that table of values right below it, okay? I want you to think about kind of like riding a bike. When you guys learn how to ride a bike, let's see if I could just kind of draw a little bike here real quick. It's going to be kind of bad. There's a little handlebars. And let's draw like a little seat here. Okay, so there's my little seat. When you guys learn how to ride a bike, generally, most times people have training wheels on them, and you have to have your little training wheels on the side. And I want you guys to think about how when you guys graph lines, it's a lot like this table of values is a lot like needing training wheels on your bike. Eventually, you take those training wheels off, and you don't need the training wheels anymore. Kind of like what we just did, I didn't need to look at any of these points to graph this line. So the goal of today's video is for me to actually just give you the equation, and you can come up with the line without needing this table of values. Now, to prove that I'm right, if I plot the point 2, 6, if I go over 2, up 6, there's that point right there in red, so that checks out. If I go over 1, up 3, that point checks out. 0, 0, that point checks out. And if I go back 1, down 3, that point checks out. So all of these points are in fact on my line. But I'm kind of trying to take the training wheels off of the bike here now, and I'm trying to be able to just graph the line without needing to look at and plot all these points, okay? So let's not look at this. I'm going to scroll up again. Let's look back again at this one. These were the two from the other page that we had just talked about. So we've got now the 1/2 x. So this time your coefficient is already a fraction. That already shows your staircase movement up and then over. This staircase we needed to make it a staircase by putting it over 1. This one's already a fraction, so we're set. Now we know a key feature of proportional graphs, y'all, anytime you see multiplying by x, it's going to go through the origin. And then this time, my staircase, I'm going to go kind of up 1 over 2, up 1 over 2, up 1 over 2. And let me just plot some points along the way. And remember, the goal is to do this without actually seeing the staircase, but I'm just going to leave it in there for now. And then since I'm running out of room this way, I'll just let the pattern kind of fall in line this way by going down 1 and back 2, and then down 1 and back 2. And so again, here we have our little line. And now I'm going to come through and I'm going to erase my staircase there. I don't like that. I don't need that. So again, from the origin, I had a point here, here, and here. And let's make sure we put our little arrows. Cool. So we now graph the line, the proportional line, y equals 1/2 x. And now let's just make sure we're right by checking out this table of values here. I've got a -6 and a -3, so back 6, down 3. Boom, boom. Hey, there's that point. Back 4, down 2. Back 4, down 2. There's that point, my origin. And if I go over 4, up 2, over 4, up 2, so those points, if I had connected them, then I would get the same line. So again, the goal is to try to do this without seeing that table of values, okay? Now, given our equations, y equals mx, so up here it was y equals 3x, here it was y equals 1/2 x. Anytime you're given that equation, y equals mx, you know you've got a proportional relationship, and you can use m, the coefficient, written as a fraction, to build your staircase, okay? Sometimes m will already be a fraction for your staircase. Sometimes you need to make it a fraction by putting it over 1 so that you can build your staircase, okay? Now this staircase is actually called that rate of change. The slope is called the rate of change. And I mentioned that in a previous video. Let me see if I can find that. The slope, we talked about that in your previous video. I had that it was the rate of change. I'm trying to find it. Sorry if I'm getting a little confusing here. We already said that m was rate of change. Yeah, right there at the bottom of page 4, we had said that the coefficient, the slope, is called the rate of change. Now, what do I mean by rate of change? It's the rate at which you see the change in y values compared to the change in x values. What do I mean by that? Let's go back to the table of values. Let's look at only the y values. What's happening here? From 6 to 3 to 0 to -3. Do you guys see that these y values are changing by minusing 3 every time. We're minusing 3 every time. So the change in the y values was a negative 3. Now what's happening on this side? See how we're decreasing by 1 every time? Minus 1, minus 1, minus 1. So the x values are changing by a minus 1. So if we have a change in y is negative 3 and the change in the x's is a negative 1, that right there, the rate of change is a 3. So our rate of change for this table of values is a 3, which is the coefficient. And there it is, the equation y equals 3x. When I say that the rate of change is the slope, which is the coefficient right there, that's what I mean. Let's try it again in this one. So let's see what happens in this one. Let me erase my rate of change over here. And we found the rate of change in y equals 3x. The rate of change here is a 3. Okay, the rate of change was this 3, m. And the way I got this 3 was I did the negative over the negative. So m here is 3. That's my rate of change. Okay, that was my rate of change. Now let's look at this one, okay? So this time, if I'm going from negative 3 to 2 to negative 2 to 0, let me check real quick just mathematically. I'm the teacher in the background checking something. These are going, I want this to be a 1. Let's make this a 1. That's a typo, y'all. Let's make this a 1, okay? All right, sorry, that's my bad. That should be a 1. Let's fix that. And now we can see it's going plus 1, plus 1, plus 1. Cool. And then that would go right here. And then the x's, you see how this is going up by 2? And then this went up by 4. Oh, I'm going to pause my video and I'm going to fix this and then I'm going to have you guys hit play and I need to change a couple numbers here. That is a typo and I'm realizing it now in the video, but I'm already 17 minutes into the video, so I don't want to have to re-record it. Let me just fix this real quick and then when I hit play again, it'll be fixed. All right, I'm really sorry about that. I don't want there to be any confusion. That's completely my bad. So it looks like this bottom one was a straight up typo. It should have been, all right, if you're watching this right now, you can see that I had to stop again because I wanted to come over and just create this new table. This first point was good, this second point was good, and I'm still keeping 0, 0. I just wanted to this is a bad point, and I'm moving this down, and I needed to put one more point in there, okay? So we're going to forget about this table of values. Sorry for the confusion. And I'm basically going to have a whole new example right here. So that was a typo. I need to fix this table of values. I already just fixed it in my notes actually for next school year so I don't forget. And sorry that happened in the video. But here we go. So let's look. We're forgetting about this. Let's focus on this table of values, okay? We're looking at the rate of change. So we're going to look at the y's. I see that this is coming up by 1. Up by 1. I'm getting closer to 0. So these are increasing by 1, which is okay that I have that here. And then here, this is going up by 2, up by 2, up by 2. So the change in the x values increased by 2. So here, I can see that my rate of change would be a 1/2. And that makes sense because my equation for this table of values, let's see if the 1/2 x works out. If I do a half of -6, I get -3. Half of this works out, so it works out that the half is found by looking at the change in the y's and then over the change in the x's. And so the rate of change here is the 1/2, which again is the same thing as the slope right there is the 1/2. So we've got some math synonyms here, y'all. When we look at the equation, the coefficient, the 1/2, is now called m, which is now called the slope, which is now called the rate of change. So lots of new words here for that, okay? Now when we flip over, we're just going to practice here now. We're going to practice just graphing these equations. And I have the table of values still on this page so that we can check the points if we need to. So here, my coefficient, the 4, is my rate of change. And I'm saying that my y's will go up by 4 while these go up by 1. So look at this. Here's up by 4, up by 4, up by 4. So there's a plus 4. Here we're going up by 1, up by 1, up by 1. So it checks out that my rate of change is the 4 over the 1. That checks out. All right, we know that proportional graphs always go through the origin 0, 0. So on the y-axis, when this goes up by 4, this went up by 1. This goes up by 4, up by 1. And you can see that I estimated like at a 7, the 8 would be there. All right, and then I could say, well, I could go down and back, and then down and back. And here is my proportional line y equals 4x. You've got here, and your staircase is the up 4 over 1, up 4 over 1. Every time this went up 4, this increased 1. Then this went up 4 while this increased 1. The y's went up 4 more, and then the x's went over 1. So again, up 4 and then x1. Up 4 and then x1. All right, the only thing I'm missing is my little arrows. Ka-ching, ka-ching. All right, and we are set. All right, now if we wanted to graph 1/5 x, my rate of change is a 1/5, so let's verify it in the table of values. My y's, this again is the change in the y's, and then this is the change on the x's, so let's look at that real quick. So here, this goes up by 1, up by 1, up by 1, so yep, these are definitely going up by 1 every time, so plus 1. And here, this is increasing by 5, increased by 5, increased by 5, so there's the 5th, or the 5 I should say. And if you look at the points, if you divide by 5, divide by 5, divide by 5, divide by 5, that is the same as the 1/5. So our 1/5, or dividing by 5, checks out everywhere here. And now again, we're going to plot. It's going to start at the origin. And we're simply going to go up 1 and then over 5. Now we're going to really run off the graph here. So let's go down 1 and then back 5. And even though we're off the graph, I have these 2 points right here. That's enough to connect. And there's my proportional line, 1/5 x. Okay? All right, now for 2x. Now again, my rate of change needs to be a fraction, so I'm going to make the 2 a 2 over 1. We'll start at the origin. And from the origin, my staircase, I'm going to go up 2 and then over 1, up 2 over 1. Every time my y value increases by 2, my x is going to increase by 1. And let's check down here. Do y values increase by 2? Yep, these increase by 2. These are getting bigger by just 1. So 2 over 1, there's my 2 over 1, which is the 2. And we can even verify, if we think back to a couple videos ago, if I just said, hey, looking at this table of values, what do I got to do to this to get this? You'd be like, oh yeah, you just double it. So you'd be like, oh yeah, that's just a 2x. So the 2 is my 2 over the 1 right here. And I can use my line to connect. There we go. And now we haven't seen one like this where it's like a 2/3. We've seen like a 1/2 and a 1/5 and stuff like that. If it's a 2/3, cool. You're going to go up 2 and then over 3, up 2 over 3. So the rate of change this time from the origin, we're going to go up 2 and then over 3, up 2 and then over 3. And again, if I'm running out of room, I could keep the pattern going by, if I went this way, down 2 and back, and then down 2 and back, because I can still show the staircase here. There's my up 2 over 3, up 2 over 3, up 2 over 3, up 2 over 3. So my staircase will still work out. Okay. All right, let me get that point back. And whoops. There we go. That's good. And let's connect the dots. Yeah. Now the reason I actually put this one on here is because if we come down here, y'all, see how it's not as easy to spot that you're doing a 2/3 and a 2/3 and a 2/3? Kind of like it's really easy when you see times 2, or it's really easy to see times 4 times 4. It's really easy to see those. Sometimes it's not easy to spot, so that's why your rate of change, let's look here on the staircase. This is going here, this went up by 1. This went up by 1. Now right here, this might have happened again. The same thing I think happened in my table of values here. Let's just forget about this point for right now. Let's just scratch that out for right now. So these are going, this went up by 1. Oh no, I need to scratch this out too. Hold on, give me 1 sec. Let me make these points a little bit better. So if this is going up by 1, this would be a 0. Whoop, and then a 1. And then these are going to be going here. Man, I messed this up again. Sorry, y'all. Don't kill me. Don't kill me. Don't kill me. All right, this time it was, I just needed this right here. This was the only typo. That just needed to be a 0. That is so annoying. This is the same. This looks good. This was good. This is good. So my bad, y'all. It was just one little teeny tiny typo right there. We just need to make that a 0. And now we can definitely look at the rate of change. I can get rid of that because now I fixed it. There's just one teeny tiny thing, and here we go. Here's my +2. Here's the +2. Here's the +2. Here's the +3. Here's the +3. Here's the +3. So your change in y's over the change in x's, that's going to show that on the y-axis you went up by 2, and then we go over to the right 3 on the x. We go up 2, and then to the right 3. Here you're going to go up 2, and then over to the right 3 on the x-axis, and that's your staircase. So it makes sense then that we say we've got a staircase of 2/3. And our equation here is y equals 2/3 x. That matches the table of values. And on this video, all we did was go through how to build the staircase without needing the table, but I left them there so that we could use them to check. And briefly, real quick, let's just flip over. See how I got rid of the table of values? I don't need them anymore. So if you don't have your table of values, I just want to point out how easy this unit really is. If it's proportional, because you've got something times x, start at the origin, and then just use that rate of change, the coefficient, to build your staircase. This time it's a 5/3, so I'm going to go up 5 and then over 3. And I'm going to run out of room. So I'll just go down 5 and back 3, and there I have my line. Okay? So that's the equation, 5/3 x, graphed on the coordinate plane. If we saw 1/4 x, again, it's going to start right here at the origin. And my staircase, my rate of change is a 1/4. So I'm going up 1 over 4. And I could go down 1 back 4. I could estimate that 8 is about right there. But again, we don't always have to go off the graph. And that would be the 1/4 x. Okay? All right, if it's not a fraction, make it a fraction by putting it over 1. So this rate of change is a 5 over 1. So we'll start at the origin. Oops, let me make that a blue point. We'll start at the origin. And we're going to go up 5 over 1. Again, we ran out of room, so I can put down 5 back 1. And there is my staircase. Up 5 over 1, up 5 over 1. No table of values needed. We don't need those training wheels. We can go straight from the equation to the graph by just using the coefficient, our rate of change. And for the last one, I'll go ahead and put it at the origin. My rate of change this time is a 1 over 6. So this time I'll go up 1 and then over 6. And I ran out of room, so I'll have to go down 1 and back 6. Straight line to connect. And we have just very quickly, very quickly graphed 4 proportional equations without needing any table of values. All we did was look at the coefficient and kind of visualized our little staircase in the background. Here it was a 5/3, so I went up 5 over 3. Here it was a 1/4, so I went up 1 over 4. Here, when it wasn't a fraction, I made it a fraction, and then I got my up 5 over 1, up 5 over 1. And here's my up 1 over 6, up 1 over 6. And that concludes the video for how to graph proportional equations on the coordinate plane given y equals mx. Thank you for watching.